So, 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 um, so,
3, 2, 1, 0.
The Null Channel.
hello and welcome to the Null Channel. My name is Merrick Counts, and today I'm going to bring you part 2 of Kubeflow. Now, I want to warn you that when I say part 2, I really mean part 1, and the first video I released on Kubeflow and machine learning in general is really part nothing, part 0. Let's say part 0. It's like a taste of what's to come. So I realized after releasing that video that I made a few mistakes in making it. Not that anything in the video was incorrect per se, but that the context of the video was very hard for somebody that was trying to glean how to install. So what I want to do is I want to take a step back in this video, explain some of those challenges, and then make some follow-up videos that go into depth on those subjects. So the first issue that I personally had with the last video was there was no context of why. Why Kubeflow? What is Kubeflow? Nothing really. I mean, there was a little small amount of chatter at the beginning, but there was no context into why Kubeflow might be interesting and might solve a problem for machine learning workflows. So I want to cover that today. So in today's video, after I cover a few of my other problems with the previous video, I want to cover why you want Kubeflow, or, and I'll get into details on that, why you don't want Kubeflow. So the other thing that I failed miserably at was how Kubeflow installs. I installed it, and that works in a very specific set of scenarios. But that doesn't really help. And here's why it doesn't help. You're installing Kubeflow on Kubernetes. And Kubernetes is master of a billion configurations, whether you're running on Red Hat's Kubernetes, whether you're running in GCP or Azure, or there are lots of configurations. And then even on top of that, you have more configurations on top of that. So what type of CNI do you use? Do you use Flannel, Calico, Cilium, Weave? What container runtime are you using? Do you use Docker, Containerd, Cryo, RTK? There are a lot of different ways. What distribution are you running on top of? So I say all of that because it's very important that we don't worry about making a standard install. What I want to do is cover how Kubeflow installs, what are the major points, and more importantly, how to configure it for what you're running on. Because if you run with Cryo and not Docker, you need to change to PNS, process namespace, executors, because if you don't, the pipelines won't work. Also, if you're running on Cryo, there are also some other steps that you need to do because there are some security best practices put in place that make Cryo a little bit more secure than Docker, but you need to open some of those up to use Kubeflow because they use them. So these are the types of things that when you're going to deploy Kubeflow, you need to be aware of, because if not, just following the instructions I said won't work, just won't work. So the third thing that I really missed in this Kubeflow install that would be very helpful, I think, is how to do a local install. So quite frankly, if you're just learning Kubeflow and whatnot, you want a local playground so that you can play around with pipelines. You can play around with just learning and understanding. You can play around with configuring it on your local machine. And I didn't give you that. So really, that very first video gave you very little tangible, useful information. So what I want to do is cover all these in probably at 3 videos. This first one's going to be on why. The second one is going to be on how to configure Kubeflow and how it actually installs itself, what Kubeflow is in the Kubernetes sense. And the third, let's set up a local install that's going to just work, because that's important. That way you can play around with it. That way, if you are setting this up in your cluster, you can give your data scientists an easy to install thing locally so they can start getting accustomed to it themselves. I think that it's important for us to have a base understanding of why, even if let's say your company uses Kubeflow and so you're going to have to. I still think that it's important. And the reason is these are all tools that we have in our tool belt. There is no silver bullet in anything. And so it's important to understand the why, even if you're going to use it anyways. So I think I always want to start these series with a why so that we know why and when it's useful. It's just great information. And it helps us explore the product and understand its shortcomings and not try to do stuff with a product that it's not meant to do, because you're always going to have heartache with that. So what does Kubeflow solve? My point of view, Kubeflow solves all the other little bits to machine learning. So when you think of machine learning, you think of training a data set. And what else is there? I mean, that's it, right? No, you need to serve it. You need to do hyperparameter tuning. You need to build a pipeline for it and all these other little ancillary things. So this is where Kubeflow comes in, because if you wanted to just train a machine learning model, Kubeflow isn't for you. You can go and you can pull a Docker image. I will actually link it in the description. You can pull a Docker image that has TensorFlow, it has Jupyter Notebook, and it has GPU drivers all in the container that you can go pull and run in Docker. You can be up and running and training something with a Jupyter Notebook in 10 minutes tops. That is what you want, not Kubeflow. The goal of Kubeflow is to solve all these other little bits. So I'm not saying it's bad. I'm just saying that Kubeflow was designed to solve these other bits in machine learning. That's it. All right, so let's look at these different bits that Kubeflow gives us and which problems that each of them solve. All right, so this is the main Kubeflow dashboard. And there's 4 main things other than home. Home is just an overview. So, but the first thing that I want to bring your attention to is not the main sections, but it is the namespaces. These namespaces might look a little confusing at first if you're not very familiar with Kubernetes, but these namespaces are very powerful for multi-user, and Kubeflow is set up in a way to enable many people to use the same instance of Kubeflow and not be able to interfere with each other's projects. So it is meant to be used by multiple people at the same time. And namespaces helps you segregate all of that. It's powerful enough that it actually allows you to denote resources that are allowed to be used for a namespace. I think that's one of the really cool features that Kubeflow thought and baked in at the very beginning. Moving on from the namespaces, we can hit up pipelines. To me, pipelines are really the crux of Kubeflow. It's the glue that makes Kubeflow what it is. Kubeflow pipelines deserve their own set of videos that I plan to make later this year. If you would like to see those, make sure that you like and subscribe to this video and leave me a comment letting me know that you'd like some videos on Kubeflow pipelines. Kubeflow pipelines is basically at a very high level The Jenkins pipelines, they let you build your workflow. It allows you to do your training and make it all a one big pipeline with a flow to it. This is each node of a pipeline has inputs and outputs, and those outputs go to other nodes, and it allows you to build out this flow of work. It allows you to visualize it, as you can see here. This is a pipeline. Each step of a pipeline is a container. It's a self-contained container, and the pipeline gives you this cool graph of all of these nodes. And all of these nodes is its own container that's running its own job with its own inputs and its own outputs. Like I said, pipelines deserve their own series of videos. They will be coming. The next thing that we have is Jupyter Notebooks. But as you can see here, it says notebook servers. And this is a really cool thing that they thought of ahead of time. So they didn't just give you a Jupyter Notebook server. They gave you the ability to make Jupyter Notebook servers with different requirements, different versions of your machine learning frameworks. Because it's all based off of containers. They're just containers with these things in them. You can give them different amounts of resources. So how much RAM and whatnot and storage that they all have access to. So not only can you cordon these off with namespaces, but you can also do it within a namespace for resource allocation. And it is an amazingly powerful tool. So this brings us to what I pronounce as Hatib, because that's kind of the Arabic, but the Arabic I think has an H. So I'm not perfectly, it's either that or Katib, but I don't think it's Katib. So what this gives us is hyperparameter tuning. Sometimes you'll hear it called hyperparameter optimization. But anyways, this is tweaking the things that aren't learned. So things like node weights are learned, and that's not a part of hyperparameter tuning or optimization. So things that are things like learning rate, and Hatib can change these things automatically. So it does this hyperparameter tuning automatically, all by itself. What it does is it uses a target like accuracy. So when it trains a model, it will see how accurate it is. How does it do that? It does it by comparing it to a data set that wasn't used in the training and sees how accurate it is. And then it can adjust some things and make some experiments to see how it can get the most accurate model. So this is hyperparameter tuning, and Hatib does this for you. So you can just build it into your pipeline and you're done. So the last thing on that list is the artifact store. And I think the website does a perfect job of describing it. And it is for tracking of artifact metadata. If you're a little confused as what that means, I was too when I first heard the terminology, but really the artifacts are just the things that get passed, the objects that get passed between those pipeline nodes. So I know how I talked about those nodes being pipelines. So the outputs and the inputs between each of those nodes are the artifacts. And this is a library of all those artifacts, so you can see what's getting produced at each step. All right, Merrick. So you've covered the dashboard. That's great. Good job, Merrick. But is Kubeflow going to lock me into TensorFlow? And the answer is no. Not really. If you're really a Seldon Core serving fan and that's what you want to use, you can use it. It works. But it also works with other serving solutions. Kubeflow is built in a way to be extended. If you want to use MXNet, there is an operator for MXNet, and you can use MXNet to train your models. If you want to use Merrick's special built-in secret training mechanism over here, you could do it. You would have to build your own operator, but the framework is there to support it. All you have to do is provide the operator. So that goes with serving and everything else as well. It is all built compartmentalized so that you are able to extend it. and extend it pretty easily. So if you want to use a special new machine learning framework, you can. You'll just need to build your own operator. And if you don't know what an operator is, this is a Kubernetes term, and that is how they handle the ML frameworks that are deployed. So I plan on making a whole series on Kubernetes operators in the future. Make sure to leave me a comment. So is that all that Kubeflow does? And the answer is no. There are a lot of things like Fairing that extend this and that are very interesting. I'm not going to have time today. This episode's already going on too long, and I need to work on wrapping it up. But it is meant to be extended, and there are projects to extend Kubeflow that are popping up all the time. All right. So now that I've sold you on why you should be a huge fan of Kubeflow, now let me tell you why you shouldn't, at least for now, use Kubeflow. And my very first thing is, until like 2 weeks ago, there wasn't a major version released. It was only 2 weeks ago that the very first major version 1.0 was released. So it is still very bleeding edge. So if you are going to adopt it with the understanding you are on the bleeding edge of machine learning, which is a bleeding edge technology. So you're like on two bleeding edges. All right. So that's my first strike against it. It doesn't mean that you shouldn't use it, and it doesn't mean that you shouldn't plan on adopting it. Just understand that it is new and it's moving quickly. All right, my next complaint comes from just the complexity. If your team doesn't understand Kubernetes and you don't have a team of people managing Kubernetes clusters for you, stay away from Kubeflow. You're going to need a team of people managing your Kubernetes cluster. Unless if you run on GCP, and even if you run on GCP, I would say that you need a team of people that understand and know Kubernetes to manage it. And because of that complexity, if you're not running a Kubernetes cluster for any other reason, and you don't have the people there with the expertise, I don't think it's worth your time. I think you'll spend more time dealing with Kubernetes than you will save by using Kubeflow to do these. There are other projects that don't rely on Kubernetes that I think would better suit your needs. Now, I can't tell you which one is my favorite because I don't personally use those. I do a lot of Kubernetes stuff, so I can't give you a recommendation. I will give some links to some of those. So if you're looking for those, I will give you some links to some of them. I have no recommendation. Along with that, if you have a small number of data scientists, do you want the extra complexity of Kubernetes? And not only Kubernetes, Kubeflow is not a simple install. As you will see later on in the series, it's not a simple install. So you really want a team that knows Kubernetes really well, because it's going to break at some point and you're going to need to fix it. And you're going to want people that know how to. I know you're going to say that Kubernetes is there so that it won't break, high availability. And yes, that's partially what Kubernetes does and the self-healing, but you have to make sure that your cluster is in operation and is operational. And it's hard. It's a hard problem. My last one. So as my last complaint, if your team isn't big into microservices yet, and this kind of goes alongside with if you haven't been running Kubernetes yet and don't have a team to manage it, it's not for you. Kubeflow is all about microservices. And honestly, I think that too many startups and very small corporations jump to adopt microservices and some other technologies before it's actually needed. These technologies solve an important problem, but only at scale. And if you haven't hit that scale, you're actually causing yourself problems. These are tools. You should know when to use them. I actually have a series planned on when and why to use Kubernetes and when and why to stay away from Kubernetes. If your company has 20 engineers and 2 data scientists, I don't know that it's worth your effort to try to run a Kubernetes cluster just to get Kubeflow. So I didn't discourage you from Kubeflow. Where do you start? So you're probably going to want to wait for my next 2 videos to come out. The next one is going to cover Kubeflow configuration and install. And it's going to go into depth on these subjects so that you can handle your cluster. I'm going to empower you for your cluster, not a very specific cluster. And then the other video that you want to wait on is how to do a local install. This is going to be so much easier because if you want to demo something, if you want to experiment with it, experimenting on your local machine is going to be far easier and faster to iterate. If you really screw up your cluster, you can tear it down and build it up very fast. If you actually go through the effort to build a proper cluster, it takes time and effort. Not tons, but it takes a couple hours. On your local machine, you can throw it away and start anew every day, and it's only going to cost you a few minutes. So I really think that for experimenting, this is the way to go. If you're also familiar with this, you can get it set up on one of your data scientists' machines and let them experiment and get comfortable with it a little bit with the pipelines and other things before diving into the real cluster, although I don't think that this is technically necessary. All right, and if you're really dying to start today, you want to start today, this is not sponsored in any way, but if you want to start today, you should head over to GCP. I think you can get 300 free dollar credits for their Kubernetes. You can install a Kubernetes cluster fairly simply, although I have my complaints because their command line tool is broken, but you can fairly easily, through the UI, create a cluster, and then it's like a one-click install to install Kubeflow. So if you want to do that, that is a great way to get started playing around with it. You won't know all the little ins and outs, but it's a fantastic way to start learning. So if you just can't wait for any of that, I would start there. Well, thank you for joining me. I hope that you learned something today. I know that I have. If you liked the video, make sure to give it a thumbs up, hit the subscribe button, and leave a comment on what you'd like to see next. If you disliked the video, go ahead and subscribe so you can stick around and see if these videos get any better. For science.